Hi everyone, welcome back to the course manufacturing process. Today we are going to discuss about theory of metal cutting. So metal cutting is a process by which we remove certain amount of material from the workpiece to change the shape and size of a product. So there are several types of metal cutting operations such as turning, milling, drilling, non-traditional metal removal processes, abrasive cutting processes, etc. to change the shape and size of a particular workpiece to finish to get a final finished product. This is called a metal cutting operation. Today we are going to discuss about machining technology, chip formation, the force relationships and merchant equation, power and energy relationships, and cutting temperature. So as I explained before, material removal is a shaping operation by which we remove certain amount of material from the workpiece to get a desired shape and size. What are the different types of machining processes? We have three types of machining metal removal processes. They are machining, removal of material by a sharp tool like turning, milling, and drilling. Turning is done in lathe machine, milling in milling machine, and drilling in drilling machine. Abrasive process means we use abrasive particles to remove certain amount of material from the workpiece. The shape and size are changed by abrasive particles. This is called grinding operation. Non-traditional process means we remove the material by chemical acids, for example, chemical etching process, or we say chemical milling process. So without any sharp cutting edge or cutting tool, we remove certain amount of material. That is called non-traditional processes. So let us start with machining process. Here we use a sharp cutting tool. As you could see here, this is the cutting tool which has a sharp cutting edge. It has a cutting edge and the face. You see here the angle alpha, we call it as the rake angle, which facilitates the cutting operation, and chips are produced and chips are formed. So basically a shearing operation or shearing process takes place in the metal surface. When we use a sharp cutting edge, sharp tool, what happens is material will get sheared along a plane. We call it as shearing plane, shear plane. So the material will undergo shear deformation and material will be cut because of the shearing process or shearing operation. Chips are produced. So this material, the cutting tool has a positive rake angle, as you could see here. The face which comes in touch with the chip with vertical, that angle is the rake angle. It has a positive rake angle, but here it has a negative rake angle with the vertical. Now, why machining is important? So variety of materials can be machined. This is one of the advantage associated with the machining operation. Several types of materials can be machined, or removal is possible with several types of materials. So we can produce wide variety of products like screw threads, round holes, straight edges, surfaces, etc. with good accuracy and finishing. That's why machining is quite important. Now, certain disadvantages with machining are like you are removing material from the workpiece. That means wastage of materials. Time consuming. It consists of several steps. So it's a little bit time consuming operation in comparison with other type of shaping processes such as casting, powder metallurgy, and forming operations. Machining. Where is the position of machining in manufacturing operations? Normally, machining is done after fundamental shaping processes such as casting, forging, and bar drawing. Initially, the shape is produced by either casting, forging, or bar drawing. Then the final dimension is produced by a machining operation to improve the surface finish and accuracy. The final shape, finishing, and specific geometric details are obtained by machining operation. What are the machining operations we have? We have turning. Machining operations are turning, drilling, and milling. Turning is performed in a lathe machine. Drilling is performed in a drilling machine. Milling in a milling machine. Other machining operations are shaping and planing, broaching, and sewing. So fundamental or basic machining operations are turning, drilling, and milling operation. Turning is used to produce cylindrical workpieces, tapered workpieces, or screw threads also could be produced. Drilling is to produce the holes in a workpiece, milling to produce flat surfaces or plane surfaces. Other types of machining operations are shaping, planing, broaching, sewing, etc. What is the meaning of turning? Turning normally is a process which is done in a conventional or in a CNC lathe machine. Here we use a sharp cutting tool. It's a single point cutting tool which is used for cutting. The workpiece is fixed in the chuck, and as the workpiece rotates, the workpiece is rotated, and the single point cutting tool is fed along the length of the workpiece so that metal cutting is possible. So metal cutting is produced by moving the tool along the length of the workpiece. The workpiece is rotating at a specific speed. This process is called turning, which is done in a machine called lathe machine. Drilling operation is a material removal process in which material is removed and holes are produced. We use a drill bit for that. The feed is in vertical direction. Now milling machine is we use multiple cutting tools, multiple edged cutting tools to produce flat surfaces or to remove more material from the surface. Such kind of milling operations are used. So rotating multiple tool, cutting edge tool across a workpiece to produce a plane or straight surface is called milling operation. Two types are there: peripheral milling and face milling. In peripheral milling, the peripheral surface is used for removing the material, whereas in face milling, face surface is used for removing the material from the surface. Now, what are the classification of cutting tools? There are two types of cutting tools: single point cutting tool, only one active cutting edge. The point is usually rounded to form a nose radius. Turning uses single point cutting tools. This is first type. Second type is multiple cutting edges. More than one cutting edge in multiple cutting edge tools. Motion related to work achieved by rotating in multiple cutting edges. Drilling and milling are examples. If you see the cutting tools, this is a single point cutting tool. This is the cutting edge. This is the nose radius cutting edge. This is the face, rake face. This portion is called the tool shank. This is the cutting area and this is the cutting edge. So flank, cutting edge, rake face, etc. This is a multiple cutting tool which is used, cutting edge tool which is used in milling operation. It has multiple cutting edges, as you could see here. Multiple cutting edges are used to produce a plane surface. What are the cutting condition normally we use? Normally the cutting conditions in a normal machining operations are the speed, cutting speed. Then the feed. Feed means the length along which the tool is moved. Feed. Depth of cut, the penetration of tool below the original work surface. So V is the cutting speed, the speed at which the workpiece is rotated in the case of turning operation. Feed is the distance traveled by the tool in per every revolution. Depth of cut is a penetration of the tool below the original surface. So we can calculate the material removed in a process by multiplying V, F, and D. So cutting speed times feed times depth of cut will give you the material removal in material removal rate in millimeter cube per second. Let us see the cutting conditions as I explained there. For turning operation, the workpiece is fixed in the chuck, and as the workpiece rotates, the tool will be fed from, for example, left to right. This is called feed. The movement of the tool along the length is called feed. At a particular depth, or penetration to the material, that is called depth. So using which we can cut the material. The chips will be produced and we can reduce the diameter. This is the cutting condition. As you could see here, the material the single point cutting tool penetrates into the material at a depth D and the material will be cut. This process of producing cylindrical shapes or taper shapes or screw threads, etc., are called a turning operation, normally done in a lathe machine. So cutting speed F and D are important. VFD is the total amount of material removed. So what is the difference between roughing and finishing operation? Roughing operation means remove large amount of material from the work part and you will reach close to the workpiece final shape. Normally high feed and depth of cut with low speed in roughing operation. Finishing operation means final cut to produce final geometry, final dimensions, etc. Normally high cutting speeds are used in finishing operation. What is the meaning of machine tools? Machine tools are the tools or machines which are used for producing, which are used to perform a machining operation, which are used to produce a part. Examples, a grinding machine or whatever it is, lathe machine, etc. So machine tools will have several functions, like it holds a work part, it positions the tool relative to the work part, provides power at a speed, feed and depth of cut, etc. The term is also applied to machines that perform metal forming operations. So what is orthogonal cutting? It's a cutting model. Orthogonal cutting model is a simplified cutting model that describes the mechanics of machining. The mechanics of machining is expressed in terms of a model, orthogonal cutting model. As you could see here, as the tool advances, the thickness T0, initial thickness, is sheared into TC, the thickness of the chip after cutting. So the thickness of the material before cutting is T0, which is deformed and cut, to TC, which is after cutting. So thickness of the chip before cutting, thickness of the material before cutting is T0, and thickness after cutting is TC. As you could see here, the cutting force, the thrust force, etc., are acting on the material as it is rotated, and the cutting force will produce a shearing, as you see here, and this shearing action will be across the shearing plane. This is the shearing plane, and thickness, final thickness is TC and initial thickness is T0. Now we can see the chip thickness ratio. What is the chip thickness ratio? Chip thickness ratio is a ratio of initial thickness, chip thickness divided by the final chip thickness. T0 divided by TC. So thickness after the cut is normally greater than before cut. So the thickness of the chip after the cut is more than the thickness of the chip before the cut. Hence, the chip thickness ratio is usually greater than 1. So this is all about chip thickness ratio. Chip thickness ratio means it is a ratio of thickness of the chip before to thickness after the cut. Now, what is shear plane angle? I explained to you the cutting takes place across a particular plane called shear plane. So that shear plane is expressed in terms of phi. So tan phi, the shear plane angle across which the material gets sheared, is equal to r cosine alpha divided by 1 minus r sine alpha. Here R, we know what is R. R is the chip ratio. Alpha is the rake angle, angle of the tool. And phi is the shear plane angle. So phi is the shear plane angle. R is the chip ratio. Alpha is the rake angle. So using this, we can calculate or we can find the angle across which the chip forms. Now you can see here another expression for shear strain. So as I explained before, shear strain can be expressed here using this triangle. So when we use a positive rake angle tool, the material will be cut across the shear plane, and that angle of the shear plane is phi. Here, if alpha is the rake angle of the tool, then the shear strain is calculated as AC over BD. The process can be expressed in terms of a triangle, AC divided by BD. Using this, we can calculate the shear strain which is produced during the chip formation. So also an equation which is used to find shear strain, gamma equal to tan phi minus alpha plus cot phi. Phi is the shear plane angle, alpha is the rake angle. Using this, we can find the shear strain. Now, as I explained before, chips are formed. How the chips are formed? Whenever we use a sharp cutting tool, shearing force will be produced across a plane. We call it as a primary shear zone or shear plane, which is represented by an angle, shear plane angle, and the material will get sheared across that plane. And this process is called shearing operation. Shear stress is produced and hence chips are formed. Thank you very much for listening. Thank you.